Good morning, everyone. My name is Lin. I'm Engineering Director in AI Infrastructure at Facebook. Today, I will share with you a set of core features that is launched in PyTorch 1.3 and the core principle we have been following under the design. Before I start, I will do a quick recap of what is PyTorch. PyTorch is born with emphasis on 5 core elements. First, it supports eager execution through Python. It has the capability of generating graph, which can optimize for efficient inference. Second, it can allow developers to author dynamic neural network and use control flow, which is critical for NLP and translation workloads. And third, PyTorch natively supports distributed training, and it can scale computational intense part to a large cluster and process large set of data. And fourth, PyTorch leverages hardware accelerators. It produces much better per watts and per dollar, and addresses challenges handling power efficiency in data center settings. Last but not least, PyTorch focuses on simplicity, and we want to drastically reduce cognitive overhead and let developers focus on model innovation and focus on developing algorithms. All of these things are coming back to our desire to bridge 2 worlds. One is cutting-edge research, the other is large-scale production deployment. Going back to what Jeff just mentioned, starting from PyTorch 1.0, we have been focused on developing core features to accelerate the path from research to production. Here are the 2 core principles we're following very closely. One is we want to optimize for developer experience and drive developer efficiency. The second is building for scale. Driving developer efficiency, that means we want to enable high velocity of model iteration and innovation. This journey starts from clean API design. AI research is fast evolving, and PyTorch is always there to provide most convenient way for us to express models. And we enhance our API in a very careful way. For example, attention-based modeling, such as transformer, gain a lot of popularity in research and industry. We pull the most common implementation to PyTorch in a very clean and simple way. In order for us to drive research to production transition, we built TorchScript. TorchScript is an optimizable subset of Python language. It removes Python dependency in production deployment, but still preserve model as program philosophy. It also enables compilation path for performance optimization. It provides all the building blocks to express models. For example, on the right-hand side, you can see the code snippet. You define an RNN model, and through one line call, you can convert your model object into TorchScript. If there's something wrong with your model, you can disable that script call and debug in Python. Michael Suo will come on stage to talk a lot more about TorchScript later today. TensorBoard is a very powerful tool to help developers understand and debug models. We launched TensorBoard on PyTorch so you can debug and understand model in PyTorch. And TensorBoard is very useful to visualize model graph, use histogram to debug weights, look at text and image embedding projection, 3D pointers, and so on and so forth. Through the TensorBoard and PyTorch integration, we can log data using torch.util.tensorboard and process and feed that data into visualization layer. This work is delivered through strong collaboration with Google TensorBoard team. Let's take a peek into what's coming in PyTorch 1.3 for much better developer efficiency. Named Tensor is coming in PyTorch 1.3. Named Tensor aim to address the concern that we do not associate semantics closely in Tensor and in our data sets. It creates a problem that the code over course of time can be prone to error, and it's very easy to make mistakes. In named tensor, explicit named tensor, as you can see on the right-hand side before and after, we pull the tensor semantics from the comment into the code. Therefore, the code is much more readable and maintainable. Along similar lines, we are also doing type promotion. Greg will talk about named tensor and type promotion later on stage. Captain is coming to PyTorch 1.3. Captain consists of a library and a UI tool. The library is a collection of gradient-based attribution algorithms, and the visualization tool provides a much deeper understanding to interpret model and what contributes to the prediction. For example, on the right-hand side in the screenshot, you can see that through color scheme, we can dictate which text is contributing to the prediction and at what significance. We would like to support Captain and TensorBoard interoperability, and we will provide, in the future, Captain plugin into TensorBoard. Narina will come on stage to talk about Captain in more details later today. Let's come back to the two core principles and talk about how we think about building for scale. Building for scale here means to provide high-performance execution over a wide variety of hardware. In particular, here scale means we would like to scale up to run on very beefy hardware, to scale out to run on large cluster, and scale in to execute efficiently on embedded devices. First, let's take a look at how we think about optimizing for hardware backends. Our strategy is either to implement high-performance kernels or compiler, or leverage the state-of-the-art libraries and tool chains in the industry. For example, PyTorch fully integrates with MKLDNN, CUDA-cuDNN for high-speed computation over CPU and GPU. We have also integrated with the state-of-the-art quantized kernel, APGM, and QNMPACK developed in Facebook to support Intel CPU and ARM CPU. Through PyTorch JIT, we enable optimization path to integrate with Google XLA, Facebook Glow, and open source TVM. That way, we can generate best code towards specific hardware backend. Let's take a look at what's coming in PyTorch 1.3. PyTorch Mobile is coming. PyTorch Mobile is not a different framework. It supports the full feature of TorchScript. It is very important because many applications that need to launch on mobile device rely on AI to make the product experience much better. And it recently become a necessity because the latency between mobile device and server cloud is too high to provide a good product experience. And because of privacy push in the tech industry, a lot of time we cannot send the data back, or data will be fully encrypted. Therefore, doing on-device inference is much more desirable. We also look at providing high-performance execution under tight hardware constraint. For example, we can deliver 60 frames per second classification on iPhone X through quantized MobileNet. David Rees will come on stage to talk about PyTorch Mobile later today. Quantization is coming in PyTorch 1.3. Quantization is a well-established technology in industry that addresses significantly reduced memory bandwidth consumption and improve computational efficiency. A lot of hardware accelerators also only support integer processing. So quantization becomes necessary for us to leverage the hardware accelerator capabilities. In 1.3, we provide a suite of tools and workflow for developers to choose between simple ease of use and how much control you want to have over accuracy and performance. For example, you can use dynamic quantization, post-training quantization, or quantization-aware training. You can even customize your quantization workflow as needed. Dima will come on stage to talk about quantization in details later today. So I just glanced through tip of iceberg of a set of new features launching PyTorch 1.3. PyTorch core development team will come on stage to do deep dive over a much more comprehensive list of features. We'll also host post sessions, so you can come to discuss with us in person about how the new features can help you be more productive and help you launch more models in production. You can also give us feedback, and we can seek for collaboration opportunities in the future. Looking to the future, we will also invest a lot more in compiler, model parallel training, on-device technologies, so on and so forth. So please stay tuned for the new future release announcements. Thank you all very much for coming, and I hope you really have a great time engaging with the PyTorch team, the bigger community, and hope you have a great time today.